Hello students, ഈ വീഡിയോയിൽ condition for stable and unstable equilibrium of dipole in a uniform electrostatic field, continuation of potential energy. Okay, we can discuss the condition for stable and unstable equilibrium in a uniform electrostatic field. Okay, അപ്പോൾ അതിനായിട്ട് യൂണിഫോം ഇലക്ട്രോസ്റ്റാറ്റിക് ഫീൽഡ് എടുക്കുക. പൊട്ടൻഷ്യൽ എനർജി equation. What is the equation for potential energy? Potential energy U equal to potential energy capital U equal to two equations are there. PE into cos theta 2 minus cos theta 1, or the reduced form U equal to minus PE cos theta P dot T. Okay, both the equations we can take. See, according to first equation, potential energy is minus P into cos theta 2 minus cos theta. Okay, for stable equilibrium, potential energy must be minimum. What is the condition for stable equilibrium? For stable equilibrium, writing EQM, equilibrium, potential energy must be minimum. Okay. For this minimum potential energy, we should get a large negative value. That is U equal to minus PE into cos theta 2 should be 1, and this one is minus 1. That should be minus 1. So we get minus 2PE. It is a negative large value or minimum value. Negative large value means minimum value. Okay. How should we get 1 here? Theta 2 should be 0. Okay. And theta 1, for getting minus 1, theta 1 should be 180. Okay. So, theta 1 value is equal to 180 and theta 2 is equal to 0 for stable equilibrium. That is according to first equation. According to first equation, this is first equation, this is the condition. Okay, theta 2 0 degree and theta 1 180 degree. What does it mean? The dipole should orient from, this is the direction of field. Direction of field, the dipole should orient from anti-parallel position. This is our dipole. It should orient from anti-parallel position to parallel position. Okay, this is anti-parallel position. Dipole moment is opposite direction of vector E. Now the angle is theta 1 180 degree. It should orient from 180 to 0. That is, it should come like this. Vector E and this is vector P. Vector E and vector P. Okay. This is the meaning of rotating from 180 degree to 0 degree. This is according to our first equation. Okay. And if you are using second equation, it is very simple. Second equation is this one. Okay. That is U equal to minus PE cos theta. For getting a negative value, cos theta must be 1. Okay. For negative value, negative U. For negative potential energy, cos theta is 1. So we get U as minus PE. Okay. What does it mean? The dipole and electric field should align parallel. Dipole and electric field should align parallel. Okay. It is the last part of our first equation. Okay. When it rotates from anti-parallel to parallel position, we get minimum potential energy, that is negative maximum, and it comes under stable equilibrium. Okay, or you can take this equation when it align parallel to the field direction. The potential energy is minus PE, minimum value. U is minus PE, it is minimum value. Therefore, the dipole is in stable equilibrium. Okay. Second one, for unstable equilibrium, just opposite to this. For unstable equilibrium, potential energy must be maximum. Maximum means a positive value. Okay. Our first equation. First equation is U equal to minus PE into. For getting this positive value, cos theta 2 minus cos theta 1 is the equation. This one should be, cos theta should be minus 1 and this should be 1. Okay. So, theta 2, for getting cos theta 2 minus 1, theta 2 should be 180. And cos theta 1 equal to 0 degree. Okay. So, for unstable equilibrium, for this condition, the dipole should orient or rotate from 0 degree to 180 degree. That means parallel to anti-parallel position. Parallel to anti-parallel position. Okay. This is the condition for unstable equilibrium for the first equation. Okay. For the second equation, we have PE U equal to minus PE cos theta. If you are using the second equation, what we need to do for positive value, for positive potential energy, cos theta must be minus 1. That is theta equal to 180 degree. Okay. Or U equal to, we get minus PE into cos 180. Cos 180 is minus 1. So, minus PE into minus 1 is plus PE. Okay, what does it mean? The dipole should align anti-parallel to the field direction. When dipole moment is anti-parallel to the field direction. Field is acting in this direction and dipole moment is anti-parallel. We get positive potential energy and is a condition for unstable equilibrium. Okay. Then this is the case of dipole placed in a uniform electrostatic